Okay. So the next part is free radical substitution reactions. I'll tell you easy way, not that complicated. Main points you remember enough. 10 minutes it will complete. Free radical substitution. What is meant by free radical substitution reactions? Again same. The initial attack is a radical. If a substitution reaction taking place by the attack of radical, first radical is coming, that is called free radical substitution. So best example, halogenation of alkanes. Halogenation of alkanes. Examples important first. Next, nitration of alkanes, not benzene. Nitration of alkanes and even sulfonation. These three are examples. But this takes place in higher alkanes only. This takes place in higher alkanes only. Halogenation of alkanes, we will see. So halogenation means we will have chlorination, bromination, iodination, right? This is about halogenation, first category. In this, chlorination is highly explosive reaction. Highly explosive. So you can't do at laboratory. And iodination is reversible. First point you have to remember this. Only shortcuts I will go. Among chlorination, bromination, iodination is reversible and fluorination is highly explosive. This is the first point. These two generally takes place. Okay. These two takes place normally. These two takes place. Okay. Now fluorination, this is explosive now. So how to do remedy? What is the remedy for that? Do in inert atmosphere. In inert atmosphere means like nitrogen. In inert atmosphere we can do. This reaction is highly explosive and highly exothermic. That is why the energy released is like a bomb blasting. Okay, if you blast a bomb, how much energy will release? That much will be released. So you can't do. So iodination is reversible now. Then what is the remedy? It can be done. It can be done in the presence of oxidizing agents, strong oxidizing agents, like HiO3, HNO3 and HGO. This is important. Hg2O. Okay, in the presence of these oxidizing agents we can do. Then the reaction is irreversible. You can do iodination. Understanding? So like that, main points you write. Some more points, please. Okay, not teaching any mechanism, just main points only. Next, what is the reactivity of halogen, children? What is the reactivity of halogen? For Friedel-Crafts reaction means no doubt F2, Cl2, Br2, I2. Next, reactivity of alkyl group. Reactivity of alkyl group means which group can be replaced first? Tertiary alkyl group, then secondary, then primary, then methyl. Means tertiary alkyl group will be immediately replaced. Niranjan? Understood? Iodination we cannot do. Then how can you do an iodination process? In the presence of strong oxidizing agent. Okay? So why iodination is reversible? So why iodination is reversible? That we will see, children. See, CH4 plus I2 in the presence of sunlight. So generally photochemical reactions takes place in the presence of what? Sunlight or peroxide or heat or at high temperature or electricity. Okay, these are the conditions in which photochemical reactions takes place. So you will get CH3I plus this HI. This HI is a strong reducing agent. So that is why the reaction is reversible. Strong reducing agent. So here to here, what reaction has taken place? That also they will ask. So this is x minus 4 is equal to 0, x is equal to minus 4. Here carbon oxidation state I am calculating. X plus 3 minus 1 is equal to 0, x is equal to minus 2. So this reaction is what, children? Oxidation. What is this reaction? Oxidation. So I2 is a good oxidizing agent here. Normal oxidizing agent, not that one. I2 is here oxidizing agent simply. I2 is what agent? Oxidizing agent. Now this strong reducing agent, it will again react with methyl iodide to give this reaction. That is why if you done the same reaction in the presence of HNO3, then you have to write one arrow only, not double arrow. You have to write one arrow only plus HI. Okay, HNO3, or you can also write with what? I told one more thing. HiO3 also you can write. HiO3 also. Okay. So that time what happens? This formed HI will react with the nascent oxygen which is given by this oxidizing agent, anything nascent oxygen. It will form H2 plus H2O plus I2. I2 plus H2O like this. So this I2 will again react with the further reaction. Understanding? If you keep any oxidizing agent, what happens? That will oxidize the HI formed. Then no more HI in the reaction. So if you use the oxidizing agent, what happens means that is the case. Understood, children? Why iodination is reversible? And what process is taking place? Is it oxidation or reduction? It is oxidation because minus 4 is changing into minus 2. If a reaction oxidation number changes, that process is called oxidation, right? So 2 more points in this. Understood this? Reactivity. Next thing. So we will do now chlorination. Daughter. We will do now chlorination and chlorination. See, CH4 plus chlorine. This takes place normally in children. If chlorine is excess, you will get all 4 products. CCl4 is the byproduct. If chlorine is excess, first it will form methyl chloride, then it will form methylene chloride, then it will form chloroform, finally carbon tetrachloride. This is the final product. If chlorine is excess, what are the products formed? Tell me the name of these things. What is this? Methyl chloride, methylene chloride, chloroform and carbon tetrachloride. Or you can say chloromethane, dichloromethane, trichloromethane, tetrachloromethane. Names are also important. What is the common name? Second bench. Methyl chloride, methylene chloride, methylene, chloroform, carbon tetrachloride. Common names. IUPAC names: chloromethane, dichloromethane, trichloromethane, tetrachloromethane. Fine. If methane is excess, then what happens, children? If this is excess, if methane is excess, then the reaction takes place with methyl chloride only. That's all. This is the major product. This is important. One more. In the chlorination, If this is excess, this is the final product. And if methane is excess, only methyl chloride will form. Means first step only will form. No more side reactions. Understand? Simple one step here. Understand? Next. Some more points. In every free radical substitution, there are 3 steps. What are those? Can anyone tell? Chain initiation, chain propagation, and what? Chain termination. Right, children? Chain initiation, chain propagation, and chain termination. So, chain initiation, every reaction is here endothermic only. Means chlorination, bromination, iodination, all are endothermic. Remember. Whereas chain propagation step, only chlorination, bromination is exothermic, but iodination is endothermic. So iodination reaction, both the steps are endo. Both are endo. Remember, iodination, both are endo. Now chain termination, what will happen? All and this will be there. So one example just I will tell you. Simply Cl, we will get 2 Cl radicals. That is the termination step. Now this Cl radical will react with methane to form methyl radical plus HCl. Methyl radical is formed. This methyl radical will react with the chlorine again. Cl radical to form methyl chloride plus chlorine radical. So in that step, this is called that step. Whatever radicals are there, they will form normal molecules, children. Whatever radicals are there, they will form a dead end step. Okay? All radicals will combine to form this. So this is the mechanism in short, simple only. Propagation step, termination step. If you know these things, no need to write. Just remember, first step is endothermic, second step is exothermic. First step is endothermic for everyone, second step is exothermic. But for iodination, both are endothermic. Okay? So that's it. This is about chlorination. In this we will see the questions, how the reactions are asked. So next just we will see the nitration part. Nitration. Nitration is the second example. Methyl methane plus HNO2 will give nitromethane. Nitromethane. This is also an example for free radical substitution. But if you take this methane, you will get more products here. One is nitropropane. Second one is dinitropropane. Sorry, 2-nitropropane. Next, you can cut like this also. Yeah, this one once check. Yes, children. So, what is the second reaction of Friedel-Crafts substitution? That is nitration. First one is halogenation. Clear, everyone? What are the main points to remember in halogenation? One by one you tell. Last bench, listening. What are the main points in halogenation? Stand up. Main points in halogenation you tell. Fluorination is explosive. Iodination is reversible. Chlorination and bromination, it will be done. First point. Second point. Iodination can be done in strong oxidizing agents. Fine. Fluorination can be done in inert atmosphere like nitrogen. Over. Now third point. Chain initiation, everything is endothermic. But chain propagation, chlorination, bromination is only exothermic. Iodination is another. That is the third point. Fourth point, reactivity of halogen F2Cl2 Br2 I2. Reactivity of alkyl group, tertiary, secondary, primary. These are the 4 points. That's it. Any doubt? Now coming to nitration. Nitration you will get nitromethane, but if you take this is the more stable carbocation. That is the reason this will be major, remaining all byproducts will come. What are the chances, children? See, very easy to remember. Here first hydrogen can be removed, no? This hydrogen can be replaced or not? Then you will get nitropropane, this hydrogen. This and this same possibility. Here also nitropropane only will come. And if you remove this hydrogen, you will get 2-nitropropane. This is the major one. Why I wrote major? Because secondary radical is more stable. Why major, children? 2-degree radical is more stable than 1-degree radical. That is why. 2-degree radical is more stable than 1-degree radical. So 1-degree radical means like this. Because of this, 2-nitropropane is the major one. Next, what is the other possibility? This can be cut. Means here radical if it comes. So nitromethane also there is a chance. And nitroethane also chance. How can they ask the question here? Which of the following product can't be formed? Can't be formed. So they can give this. So you should have an idea. Which of the following product cannot be formed? And if option suppose they have given like this option, then this can't form. Alkene can't form. There is no chance. Okay, nitro products all can form. So if you don't know this, you may pick the answer for methyl nitrate. This can't form, you can think, but it is a chance, right? So this is nitration, children. Second example, and the last example is sulfonation. Sulfonation is also a type of which reaction? Free radical substitution. Sulfonation also. But it takes place in higher alkenes, that's all. Sulfonation. Like CH3, H is there. Isobutane. And if you add sulfuric acid form you can write like this, children. This is sulfuric acid only. H2SO4. For our understanding purpose I wrote sulfuric acid. H2SO4. Then water molecule will go and you will get CH3, SO3H. Okay. So this is also an example of free radical substitution. Okay, na? That's it. Any doubt in this free radical substitution reaction? No doubt. Okay. Next, fourth example, very important. NBS. What is NBS? N-bromo succinamide is very good reagent for allylic and benzylic bromination. This is very important. Allylic and benzylic bromination. Allylic and benzylic bromination will take place by free radical reaction. So what is that? So what is NBS? Like this. Its structure will be N-bromo succinamide. Any doubt? N-bromo succinamide. So this is for allylic and benzylic bromination. Means suppose the compound is like this. I will give you the examples of this. See, example: CH2 double bond CH2 single bond CH3 is there. Fine, children. And if I added NBS here, NBS. Now examples only run. You have to concentrate now. Last 10 minutes, 10-15 minutes. These are all examples, very important. So NBS if I have given, then what is the product? Br will come at which position? This is suppose 1, 2, 3. Which position Br will come? This is allylic, children. Double bond next carbon is allylic. So Br will come at this. Okay, that position. So this is radical substitution. This is what reaction? Free radical substitution. Suppose if I gave Br2 in CCl4, then that is which reaction? See, you ask the clues now, how to remember. Like this, compare to study only you can remember. This is electrophilic addition. It is not a substitution at all. And the product is also changing. Like this, compare to study you have to study. NBS, N-bromosuccinamide, you will get allyl bromide. What is the compound called? Allyl bromide. Whereas if you add Br2 in CClO4, you will get a addition product. So one reaction is free radical substitution example, and other reaction is electrophilic addition example. One is free radical substitution and other one is electrophilic addition. Next example, I can take a benzene ring and CH2Br, CH3. Okay, this is toluene. But benzene I can write like this so that you can understand. So here NBS if you add, then also you will get benzyl bromide. This is called benzylic position. Allylic and benzylic. So suppose this is the reaction. Same I added NBS. Then where it will come? CH3, here Br will come. And here CH double bond CH2 will be there. So this is about NBS. NBS is also allylic substitution. Allylic and benzylic mainly we will use. So this is our allylic carbon. Here this is the allylic carbon. One more example. Yes. Yes, children. Suppose NBS is there. Then where is the product formed here? Can anyone tell? There are two allylic positions. These two are allylic positions. See, the star asterisk symbol are allylic positions. Understanding? Allyl bromination. Didn't understood? Didn't understand, ma? समझ में नहीं आया? Understood? Allylic means see, double bond is vinylic, next carbon is allylic. Okay. Suppose if here bromine is coming, that is called vinyl bromide. This is called vinyl bromide. वो नहीं आएगा. Just I am telling. This is called vinyl bromide. This is called allyl bromide. This carbon vinyl bromide. This is allyl. Understood? Right. So this is children free radical substitution over electrophilic substitution over. So some more reactions we will see now. Questions only. How many chlorinated products are formed? This is frequently asked question. Methane chlorination, ethane chlorination. How many types of chlorinated products are formed? That we will see. See, this type of questions they will ask. Propane on chlorination, how many products are formed? Yes, can you tell? First question. Chlorination of propane will give how many products? Chlorination of propane will give how many products? Think. How many more? Try. Chlorine can form here, no? Then that is 1-chloropropane. Chlorine can also form here, no? 2-chloropropane. Chlorine can form here. That and these are same. Right? Very good. So one is 1 chloropropane and other one is 2 chloropropane. Understanding? So only two products are formed. In this, what is major? This one is major. Why? Because 2-degree radical is more stable. That's all. Now, if I give butane, then how many products are formed? Butane on chlorination forms how many products? Tell children. Butane on chlorination. Try exercise. How many products are formed when butane undergoes chlorination? 2. Correct. But with